Okay, we got the accelerated math objective, word problems, circumference, and arc length. A park has a circular swimming pool, and so I went ahead and drew a circle. It says the diameter is 18 meters, so I'm going to go ahead and draw in that diameter, label it as 18 meters, and I would recommend this for all these word problems. Draw a picture so you can kind of visualize what's going on, especially if you're a visual learner. It wants to know the distance traveled if you swim around the edge of the pool, and of course we've learned that around the edge of the pool or any circular object is the circumference. And the two formulas that we've learned for circumference are pi times diameter or 2 pi r. You might say, well, which one do I use? Well, if they give you a diameter, use this one. If they give you a radius, use this one. They're really the same because a radius is exactly half of the diameter. So in this formula, they're just saying multiply the radius by 2 and then times pi. So when they double the radius, they are turning it into the diameter. So here we're just going to use this formula, and notice they say use pi equals 3.14. So they're not saying hit the pi button on your calculator, but rather put in 3.14 for it. So I'm going to use this formula, 3.14 times the diameter, which was 18 meters. So we've got 3.14 times 18 and 56.52. 56.52 meters. It's not meters squared, it's meters as in terms of length. So there's our answer. Watch out for that because sometimes the accelerated math will go ahead and put a squared unit of measure on there and try to trick you into pulling in one of those problems. But on circumference, it's not going to be squared units, it's just going to be plain units, linear measurements. Okay, next one. And let's see. Allison ran 3 times around a circular track with a radius of 37 meters. So here's 37 meters. She not only runs once around it, but 3 times around it. So whatever we get for this circumference, we're going to multiply by 3, and that'll be our answer. So this time, instead of pi d, we're going to use the 2 pi r formula because they gave us a radius. Okay. Now some of you might just say, well, you know what, I'm going to double that radius and then use this one, and that's fine. That's all this formula over here is doing, is doubling it and then multiplying times pi. But once we do that, we're going to get the circumference, then we're going to multiply it times 3 because it said that she ran 3 times around this circular track. Okay, so we got 2 times pi. Now look at this. This is interesting. Use pi approximately 3. So they're asking us to put in a 3 for pi as opposed to 3.14 or the exact measurement for pi, and then times the radius of 37, and then we're going to multiply that times 3 because she ran 3 times around the track. So let's do this part first. 2 times 3 is 6, then times 37, and then times 3. So I've got 6 times 37 equals 222 times 3, and of course you can probably do that one in your head, but no, you can't. And I divided it. I did it wrong there. So 666. Ooh, sounds evil. Okay, so there's our answer, except for it's going to be in what measurement? Meters. So 666 meters, not square meters, and that's our answer. Alright, third one out of 4. Sorry, I got this covered up. Okay, the distance around the equator of Mercury is about 15,330 kilometers. Well, here's, this is a sphere, this isn't a circle, but the equator going around Mercury is a circular shape. So that is 15,330 kilometers. So this time they're giving me the circumference and they're going to ask me for the diameter. So circumference equals pi d. I'm going to use this formula because they're asking about diameter. They don't give it to me. So look what I'm going to fill in. 15,330, that was the circumference, equals pi times d. I don't know d. They want to know d. So I got to solve this for d. So if this had been 5d equals 10 or something, you want to solve for d, you would divide by 5 on both sides. Well, here it's not 5 times d, it's pi times d. So we're going to divide by pi which seems a little strange because it's a Greek symbol, but pi divided by pi, well, they cancel each other out because pi, anything divided by itself is 1, so it's just 1d or just plain d. So diameter, we got that by itself. Now we just need to do this in the calculator. What do they say? Use 3.14 for pi. So we're going to go 15330 and divide it by 3.14, and we get d, or diameter, equals 48,831. Whoa, I did something wrong there. I must have missed a, let me, because I know that's not right. Okay, did I miss a, let me clear that entry and put in that 15330. Oh, I got an extra 3 in there and I did it again. 0 divided by pi 3.14. Sorry, I get a little quick with my calculations here. So this is 4,882 point, whatever. Okay. Now, why did I know that was wrong? Because that number 48,000 came up bigger than the circumference. I know a diameter can't be bigger than the circumference. So here we go. It's answer B. It's in kilometers, not square kilometers. Alright, last one on this worksheet and we'll be done with it. I'm going to clear my calculator. Jack watched a bug crawl through an arc of 6 degrees along the rim of his melon. Jack needs to get a life. Here we got 6 degrees, and he's seeing this little bug, that's a bug, crawling that distance. And they want to know if the radius is 7 inches. If the radius is 7 inches, how far did the bug crawl? So here's what we're asking here. Alright, so we're going to put this, take this whole circumference thing a step further. The circumference is the distance all the way around the circle. Well, we want to know just a little segment. In fact, the segment we want to know is just the 6 degrees out of the 360 degrees of the whole circle. We want to know what fraction of that circumference is. So we're going to go 6, the angle measurement, over 360. That shows us how much of this circle the bug went around. If it had gone the whole way around, it would have been 360 over 360, which is 1. And then we're going to multiply that times the circumference formula. In this case, we're going to use 2 pi r because they gave us a radius. Jump over that. They gave us a radius. So we got 6 over 360. Hey, if I do that, 6 divided by 360 equals something really small. Okay, so I didn't know if that was going to reduce. I thought it would. Did I do another calculator error? 6 divided by 360. No. Okay. Oh, it might help if I. Okay, yeah. Might help if I do this right. Sorry, I get a little flustered here doing these on the. Okay, 6 goes in. This can be reduced. I'm sorry. I need to divide the other way. 6 goes into this once, and 6 goes into this 60 times. That was kind of obvious, but anyway, 1 over 60 times 2 pi and the radius of 7. Now they don't tell me what to use for pi here, so I'm going to leave it as pi, and I guess I'll use the pi button or hit 3.14 on my calculator. My calculator on this program doesn't have pi, so here's what I'm going to do. You notice this 60 is down the denominator, so I'm going to kind of put this all over 1 too, also. And now I'm going to reduce. I've got, well, you know what? I can cross reduce. That's a 1 and that's a 30 because 2 goes into that 1 time, 2 goes into that 30 times. Now I'm going to multiply everything across. On the numerator on the top I got 7 pi, and the denominator I've got just plain 30. That's my answer if the program was asking for it in terms of pi, but it's not. So I'm going to go 7 times pi, 3.14, equals that, 21.98. Pi is about 3. 3 times 7 is 21. It makes sense. And divide that by 30 to get the final answer of 0.7326. Repeating, that is in inches. Let's see if that matches up with anything. This is as close as it gets, so it must have been a little bit of rounding error because I used 3.14. Okay, that's it. If you need any help, come see me.